Today we are going to make the long, intrepid journey all the way from formula units to mass, and from mass to formula units. You might call it there and back again. Uh, that's for all of you Hobbit fans out there. All right, so here's how this is going to work. Essentially, by following, figuring out where we're starting, kind of along these three things, and figuring out where we need to end. If I just follow the arrows and do the math it tells me to do, I'll be able to get there with kind of the right units. Okay, so I've given you a shortcut for that. So let's say, let's start with 8.7 times 10 to the 24th atoms of lithium. And okay, so I know that I'm starting with formula units here. This is my start. And I want to know how many grams of lithium is that? Okay, so that means in this case I'm making the whole journey from formula units to mass. So what I'm going to do is I'm going to start by writing what I know. 8.7 times 10 to the 24th atoms lithium. Okay, it looks like that first step to get to mass, I first have to stop by moles. If I follow that, arrow going to the right, I'm following the top one. That means I'm going to take that times 1 mole of lithium has 6.02 times 10 to the 23rd atoms of lithium in it. Okay, closing parentheses. I'm going to go back and pop this in parentheses as well, just to make sure I do that kind of for the math I have. So right now I can see atoms of lithium on top, atoms of lithium on the bottom. These are going to cancel out. I'm still not at the mass of that lithium, so that means I need another conversion. In this case, I know I'm still following that rightward arrow. So that conversion I'm going to use is molar mass over 1 mole. So let's go with 1 mole of lithium on the bottom. So now I need the molar mass of lithium. Since I'm only working with 1 lithium, I don't need to go through and do any addition or anything. I'm just going to take the average atomic mass here, 6.941, and that's the grams of lithium that are in 1 mole of lithium. We kind of talked about that last time. So now, moles of lithium on top, moles of lithium on the bottom. I'm ending with grams of lithium, which is kind of what my question wanted anyway. So now when I go to type this into a calculator, I'm going to go parentheses, 8.7 times 10 to the 24th, closing parentheses. I can either do all my multiplication first or my division, or I can mix it up. You know what? Rather than talking, let's just do it. All right, so get rid of that. Open parentheses. 8.7 times 10 raised to the 24th power, closing parentheses, times 1 divided by, don't care about the times 1, so divided by, parentheses, 6.02 times 10 raised to the 23rd power, closing parentheses, times 6.941 equals 100.31 grams. So let's just go 100.3 grams of lithium. That's actually not bad. That's not a ton. It's not a lot. It's something we could measure, in our lab with our scale, stuff like that. But really why we're going to start using this is it makes it way easier to kind of figure out just what units do I need to go from where to where. Just follow the arrows. And they're going to get you to where you need to be. So with that, let's actually take a look. Let's go the other way. So let me go ahead and erase this part here. Make sure to pause it right down if you kind of want an example. So erase this quick, just because this is kind of fun to do. All right, so now, let's say that I have, let's say that I have 1,300 grams of water, H2O. Now I want to know how many molecules of water that is. Keep in mind, molecules is the same as formula units. All right, so in this case, we're not working with a single atom. We're working with kind of this hybrid thing, H2O. So let's actually figure out the molar mass of H2O. Well, oxygen has a mass of 15.999. I know 1-oct hydrogen, if I come back here, has a mass of 1.0079. Or if I could just put that in parentheses, just take that times 2. All right, so calculator time, since I'm working with decimals I can't do in my head. 15.999 plus parentheses 1.0079 times 2, closing parentheses, equals 18.0148. And that's grams of water. So 1 mole of water should have a mass of 18.0148. Move you off to the side there for a bit. So now I'm starting. So in this case, all right, so that was weird. I'm starting here, and I'm going to end here, So starting off, write down what you know. So I'm starting with 1,300 grams of H2O. I'm starting here. So my first stop to get here is I have to stop by Moletown there. So times, so that if I follow the leftward facing arrow, I can get that to go away, is 1 mole on top, over the molar mass, which we figured out is 1 mole of H2O. The molar mass we figured out is 18.0148 grams of H2O. Grams of H2O on top, grams of H2O on the bottom. Those cancel. Okay, so now I'm at moles. I need to get to formula units, so I'm following that leftward arrow there. I know I'm going to have 1 mole of H2O on the bottom. Moles on top, moles on bottom. And I know that in 1 mole I have 6.02 times 10 to the 23rd molecules of H2O. To extend my thing there, closing parentheses. Right, so now I have 1,300, or 1,300, divided by 18.0148 times 6.02 times 10 to the 23rd. All right, so really what it does is you can go step by step, go from grams to moles, and then type that in again to go from moles to molecules. But really, what you're going to see chemists do is they're going to go kind of piecemeal like this, they're not going to go piecemeal. They're going to just get all of their math laid out, and then they're going to just kind of do it. So 1,300 divided by 18.0148 times parentheses 6.02 times 10 raised to the 23rd power, closing parentheses, equals, that is a big number. All right, we're going to bring you right there. So I've got 4.344 is what I'm going to round to. So let's figure out my scientific notation here. For my decimals here, we're going to go 3, 6, 9, 12, 15, 18, 21, 24, 25. So 4.344 times 10 to the raised to the 25th, and that'll be molecules of H2O. That is how many molecules of water there is in roughly 1.3 liters of water. But the important thing, though, is we kind of went from formula units to mass, and then we went the other way from mass to formula units. So this is just working with kind of one substance being able to go back and forth between formula units, moles, mass, stuff like that. All of that balancing and chemical equation stuff we did, we're going to come back to that next time and start to look at stoichiometry. With that, good luck with the practice.